Good. It's recording now. So let's see. The first question from Chapter 3, Section 3 is number 4. F of x equals x plus 9 over x minus 2. C equals to 5. Find the derivative f as a function of x first, then f prime of c. Now notice we have what? Do you have a multiplication or a fraction? Division. So what rule are we going to use? The quotient rule. And if you remember, the quotient rule says the derivative of f of x over g sub x, it's always going to be what? G sub x times f prime of x. You can say f prime of x times g sub x. That's fine. Minus f of x times g sub prime of x, the whole thing divided by g sub x squared. So let me find all these 4 pieces, plug them in, I'm in business. What's f of x? X plus 9. What's the derivative of that while we add it? 1. What is g sub x? What's the derivative of that? Now plug them in. Let's go back. This is g sub x, which is, so f prime of x. Well, I shouldn't call it f prime. Well, let's call it y here, you know, because I'm calling the top f. So you don't mix up the notation. I'll call this y. So y sub prime of x, or dy dx, is going to be what? G times f prime. What is g? X minus 2. What is f prime? 1 minus f of x, which is x plus 9, times g sub prime, which is 1, the whole thing divided by g sub x squared. Simplify that, that's x minus 2. This will be what? Minus x minus 9. And if you simplify the top, what are you going to have? Is it negative 11? And that's your f prime of x. So that's the first answer. What is f prime of x? Is right here. That's the derivative. The second part of the question is what? Find the derivative at c. c happens to be 5. So what is f prime at 5? You replace x with 5. What's 5 minus 2? Square it. Negative 11 over 9. So that is number 4. Question on this one? No? Okay. Let's look at number 5. Number 5. Y equals sine of x over x. Again, I'm going to change f of x. I'm going to change that to y. So this way, when I label them f and g, we'll be in good shape. Again, we have a fraction. It is the quotient rule. I need f of x, which is the top. And what's the derivative sine of x? It's cosine x. There's nothing here. It looks like a dot, but there's nothing. And g sub x is x the bottom. What's the derivative of that? 1. Again, the quotient rule, dy dx, the derivative, it's going to be g times f prime minus f times g sub prime over g squared. I'm getting lazy. I'm not putting the x's there. I think you get the idea. G, which is x, times f prime, cosine of x, minus f of x, which is x, times the derivative of g, which is 1. The whole thing divided by what? X squared. If you look at the top, it looks like you can factor an x out. And see, you have an x in both of them. So if you factor an x out, what's left? Cosine of x minus the 1.
Professor, isn't it should be sine of x?
Let's see.
Yeah.
G times f prime. Oh,
Yeah, it should be sine of x times 1.
G times f prime. That's f prime, right? There? Yep. G times f prime, so that's good.
Yeah.
Minus f, which is sine of x. Oh yeah, sine of x, not x. Too bad I got excited, because that was nicer.
Yeah.
So I can't really factor an x out here. I'm going to use all my tape now. So now when you clean it, what do we have? dy dx, or the first answer, f prime, which is, they were called f prime of x. That's going to be x cosine of x minus sine of x over x squared. And the second one, what's the derivative at pi over 3? Let x be pi over 3 cosine pi over 3 minus the sine of pi over 3 divided by pi over 3 squared. And they probably want us to use the unit circle. They don't want us to use the calculator for that. I'm sure they want the exact answer. So if you got a unit circle, you're going to find where pi over 3, which is right here. And there's the cosine of pi over 3, and there's the sine of pi over 3. So the cosine is 1/2. The sine is the square root of 3 over 2. Plug them in, and we should have our answer. Pi over 3 times the cosine of pi over 3, which we said what? 1/2. Minus the sine of pi over 3. The whole thing divided by, square this, that's what? Pi squared over 9. I'm positive they're not going to leave the answer like this.
No.
It looks too ugly. So let's do some algebra here. What's pi over 3 times 1/2? Pi over 6 minus the square root of 3 over 2 pi squared over 9. Now we have three fractions, 6, 2, and 9 in the bottom. What do you think the LCD for all three of them? 18. I like that answer. Let's multiply by 18. 18 times pi over 6 becomes what? 3 pi, because the 6 and 18 will simplify to 3. Minus 9, the square root of 3, over what? 2 pi squared. That's probably the answer they want to see. Which one is this, number 5? I doubted they want the answer in decimal.
Huh. Well,
No,
they took it in decimal.
they did?
I was just curious how to get to the format that they had.
Is that what the format they had?
It's similar. Well, yeah, I had sign of X over X, yeah.
You know what? They took out the 1/2 in the front.
Yeah.
They probably can factor the 1/2 in the front, I'm assuming. 3 pi minus. Oh no, you know what they did? I'm looking at their answer. They factor 3 out. The answer they showed me on here,
Okay.
but they took this.
Pi.
If you factor the 3 out, you have 3 times pi minus 3, the square root of 3, over 2 pi squared. Really doesn't matter which format, but that's what I'm seeing for that answer. Yes. Question? No, okay. I talked to a few people at the end of each class, and I said, I guarantee you, by the time we finish this course, your algebra is going to be probably 10 times better than when you came into the course. Because they want everything simplified, or at least I think they want everything simplified. If that was me, that's how I want the answer written. This one, when I saw this, I got excited. I said, oh, this is a nice one. Actually, I love this question.
Which one's that, number 8?
That's number 8.
Is that 3.30?
Still, oh yes, all 4 of them are 3.3.
Okay.
Nick. This is 3.3, number 8. F of x equals x minus 11 over the square root of x. Now, I'm sure your first reaction, quotient rule, fraction.
Mm-hmm.
But if you looked at it closely, you don't have to do it that way. Why? Let's look at that. What does it say? It says x minus 11 over x to what power?
-1/2.
Well, right now it's a 1/2 on the bottom. You want to bring it to the top, you can. Or, that's what you want to do, x to the negative 1/2. I like that idea. Times x minus 11. If you multiply it through, what is f of x? I didn't even try the derivative yet.
1/2 X.
It would be x to the 1/2 minus what? 11 x to what power? Negative 1/2. Do I need to use the quotient rule? No. What's the derivative of that? 1/2 x to what power? Negative 1/2 minus 11 times minus 1/2, that becomes a plus 11 over 2 x to what power? Subtract 1 from that power? Negative 3/2.
And it'll accept that, but it does go a step further.
I'm going to go further, actually, because, yeah, even if they like it like this, I'm going to simplify it. I'm like the book. I like to simplify things. So what this one says, 1 over 2, x to the minus 1/2, that's x to the 1/2 on the bottom, which is the square root of x. 11 over 2, x to the negative 3/2, that's the square root of what? X to the third. I can simplify that a little bit more even. I can take an x out of this, right? And if you really want it, can you factor anything?
You can take LCD.
Yep. Oh, well, you can. But even if you just want to factor something out, look in the bottom. What do you see common to both of them?
2 root x.
You want to take 1 over 2 the square root of x? What's left there? 1 plus what? 11 over x? The book might not take the square root of x. They might just take the 2 there. George, I'm not sure. Some people would like to have the x's together. So if you just took the 1/2 out, you'll have what? 1 over the square root of x plus 11 over x the square root of x. I'm not sure which one they will like. This is good.
They have x plus 11 over 2x to the 3/2.
X plus, LCD. Then they did the LCD, right? Because if you find the LCD here, which somebody recommended, let's find the LCD.
Yeah, okay.
So you multiply both sides by x. So there's multiple ways to get that answer. But notice instead of using the quotient rule here, I opted, let me simplify that, and why use the quotient? That's a lot quicker. It's just the simplifying part took a little bit longer. Or trying to figure out which answer they wanted.
Professor, one quick question.
Yep.
You have x to the negative 1/2 times x. Why isn't that x to the negative 1/2 itself?
X to the negative 1/2 times x, that's x to the 1/2. Is that what you're asking?
Yeah.
Why?
Why?
Because when you multiply, you add the exponents. What is the power of x here? 1.
First.
1 minus 1/2
Okay.
is the 1/2.
Thank you.
You're welcome.
So can we leave it like that? We don't have to rationalize it?
Well, he said they'll take any answer.
Okay.
This. If you want to find the LCD even, notice the LCD for this will be what? If you want it, you can go multiply this to top and bottom by x. Which will give me what? X plus 11. Is that what you said the answer was there?
Yeah.
Okay. I'm sure they'll probably take any of the answers. Yep.
It ends up just being either 2/3.
Yep. If you don't want, leave it like this, you can write 2/3. Yep. And the last one, again, still in section 3.3. The last one is find the second derivative. Again, I don't like to call this f, so we'll call it y. So I can use the quotient rule. This way there's no mistake in which one's f, which one's g, and all that. So f of x is equal to x. The derivative of that is equal to 1. G sub x is equal to what? X minus 9. The derivative of that is also 1. Quotient rule. So I got to find the first derivative first. What is y prime of x? G times f prime minus f times g sub prime, all divided by g squared. X minus 9 times f prime plus f, which is x, times g sub prime, which is what? 1. The whole thing divided by x minus 9 squared. Simplify it. X minus 9 plus x which is what? 2x minus 9. And in the bottom here, it's going to be x squared minus 18x plus 81. Notice I opened it because we didn't cover how to take the derivative of something raised to a power yet. That's shortly. Coming up in a few minutes. So right now, my best bet is actually to open it and now apply the quotient rule again. Go ahead,
Is that a
Jordan.
plus?
Yeah, I was gonna say.
Which one?
In the numerator, why is that a plus?
2x.
No, above that.
Above it.
Step above.
Oh, that's a plus.
Yeah. it
Yep.
should be a negative.
X and x.
Well, you're subtracting.
Oh, I see what you're saying. Subtracting.
So it should be,
Oh, the x's are gone actually. Yep.
yeah.
See, I need you guys here. People say, do I have to come to class? I can watch the videos. No, because I make a lot of mistakes.
Okay. Yeah, this is where I got stuck.
So now we're going to take the derivative of this. We're going to repeat the process. Let's do it again. So let's look at this function. Let me write it down actually, so I don't have to keep looking on the other piece of paper. I can just take it and throw it on the side now. And now I'm going to take the derivative of this. The second, here we go, the quotient rule. I'm going to call f of, I'll use different color here. I'll call f of x here is the top, which is negative 9. And what's the derivative of that? 0. The bottom, which is, by the way, in case you remember, that was what? X minus 9 squared, was it? And what's the derivative of that? 2x minus 18. Yep. So the second derivative g times f prime minus f times g sub prime, all divided by g squared. G, I can write either this or that. Well, I'll write that one. It's cleaner. So it's going to be x minus 9 squared times the derivative f, which is what? 0. I don't know if you noticed by now, I always put the derivative in square. Minus f of x, which is what? Negative 9 times the derivative of g, which is what? 2x minus 18. All divided by g squared. If this is g, x minus 9 squared, what happens when you square it? 4. Oh, I like that. What first piece is going to be 0. That becomes plus 9 times. Let's look at 2x minus 18. What can you do with that? Factor out of 2. Yep. 2 times what? X minus 9. So I took a 2 out of that. What's 9 times 2? 18 over x minus 9 to what power? To the power 3. Why? Because there's one of them here and there's 4 on the bottom. This one cancels one of these, making it a 3 here. So it's 18 over x minus 9 cubed, and that's your second derivative. That's dead. Yes?
Did you go over the last one as well? Number 20?
20. Okay. How about this one? Any question on this one? Let's see, what's 20? I was looking at the clock like a hawk, but I forgot. YouTube doesn't care how long the video is. 20. Oh, 3 not 30. Boy. I'm already on vacation, I guess. F of x equals cosecant x, and the question, find the second derivative. Well, let's find the first derivative. Derivative cosecant, if you memorize them, is negative what? Cosecant x, cotangent x. Remember that? That's the first derivative. Done. I should call this y again instead of f. You'll see why in a minute. To get the second derivative, I got to take the derivative of this. Well, what do we have here? Multiplications. So I have to use the product rule. That's why I changed the name to y. So I'm going to call the first one f of x. I'm going to call that negative cosecant of x. And I'm going to call the second one g sub x. So g sub x equals cotangent x. F of x equals negative cosecant x. What's the derivative of each one? But I have already a minus here. So minus a minus, I'll make it a plus, right? Cosecant x, cotangent x. Usually it's a minus if it's a cosecant, because of the minus sign is going to make it a plus. And the derivative cotangent, which is what? Negative cosecant squared. So the second derivative now, it's the product rule here, which is f of x times g sub x plus fx times g sub prime of x plus g sub x times what? F prime of x. Product rule. What is f of x here? Negative cosecant x times g sub prime. Negative cosecant squared x. Plus g sub x, which is what? Cotangent x times the derivative of that, derivative f, which is cosecant x, cotangent x, if you can see it. Cosecant, cotangent. Bless you.
Thank you.
Minus times a minus, positive, that's what? Cosecant cube x plus what? Cosecant x cotangent squared x. Yep. I'm looking at the solution on the computer, on the answer, and that's what they wanted. My first reaction was what? Factor out cosecant squared. Cosecant, not cosecant squared. So that's the answer. Some of you probably might decide to factor out the cosecant, which is fine. What's left? It'll be cosecant squared x plus cotangent squared x. And I was about to use some trig identities here, try to simplify that even more. But they were happy with that answer. What trig identity was I thinking about? Well, if you know by now, I don't memorize anything. I have a horrible memory. So I try to derive everything. The only thing I know, put this aside, I know sine squared x plus cosine squared x is always equal to what? 1. So we're talking about cosecant, cotangent I saw there in the problem. Cotangent, cosecant. So if I, watch this, what will happen if I decide to divide both sides by sine squared? What would you have? What is sine squared over sine squared? What's cosine squared over sine squared? Cotangent squared x, right? What is 1 over sine? How about cosecant? So I was about actually to go through it and replace, notice if I play with the math here, I can write the cotangent squared x as what? Cosecant squared x minus 1. And I was about to plug it in right here. So everything will be in terms of cosecant, but I guess they don't care. But I was just along, from the minute I saw this, I was thinking that direction they're probably going to go. But it really doesn't make it smaller. If that was 1 plus cotangent squared, then I could have took it out, put cosecant squared. Here it doesn't make any difference. And by the way, nothing to do with this problem. If you took the same one on the top, which is sine squared, plus cosine squared, and instead of dividing by sine squared, if you divide it by cosine squared, again, this has nothing to do with the previous problem, you create another identity. What is sine over cosine? Tangent squared. What's cosine squared over cosine squared? What's 1 over cosine squared? So there's a few trig identities that ties the secant and the tangent, and the cotangent, the cosecant. And they all came from the basic one, sine squared plus cosine squared is equal to 1. You can say cosecant squared equals 1 plus cotangent squared, or when you rewrite that, cotangent squared equals cosecant squared minus 1, or 1 equals cosecant squared minus cotangent. Just play with the algebra. Yeah. These might come in handy down the road, you know.